All right, this is 283, move zeros. So there's a few different ways to do this, but it says given an array of nums, write a function to move all zeros to the end of it while maintaining the relative order of the non-zero elements. So we see we have an example here. We have 0, 1, 0, 3, 12, and we want to keep this order. It's not sorted per se. We don't know if it's going to be sorted. We have to keep the relative order. So here it just kind of looks sorted in regards to this 1, 3, and 12. But you can see that this 0, these zeros, 0, 1, the 0 here and the 0 in the third in the third index here, get moved to the end. Note you have to do this in place without making a copy of the array and minimize the total number of operations. So the first way to do this, it's not going to be in linear time, but the first way you can do this is that you can iterate through the array, right? If you find a 0, count the 0, because we're going to count the number of zeros, and we're just going to place them at the end. At the same time, if you find a 0, you want to delete it. You want to remove it from the array. The problem here is that removing, worst case, from an array, when you remove an element from the array, let's just say you have 1, 0, 2, 5, 0, 8 here, and you remove 0. Let's say you remove the 0, it's gone. What you do to fill in that spot, you don't actually remove anything. What usually happens in implementations, that you either slide all these numbers down like this, or you slide the numbers at the front up to fill the space, or in case you're removing from a different area. So that's the problem with that solution there, but it will work if you do it for this problem. The other way to do this is with the sliding window pattern. So the sliding window pattern, we're going to visualize this array as a sliding window of contiguous elements. So for an example here, we have 0, 1, 0, 3, 12. What the sliding window pattern is going to do is going to allow us to visualize this as a sliding window. So if we start our loop here at 0, what we can do is just say, oh, we found a 0. That's cool. Let's see if we can go to the next index and find another 0. So in the case here, since we found a 1, what we're going to do is we're going to swap this 1 and a 0, because we want to move these elements to the end of the array. Then we're going to move the start of the window up. Then we're going to go to the next element. Since it's a 0, we can just kind of slide it up. That's dope. And we go to the next element here, we have a 3. Well, since we have a 3 here, we want to move all the zeros to the end of the array. We're going to swap 3 with 0, move our window up again. And so we're going to continue this pretty much until we get to the end of the array. So just to skip to the end here, we have 12. We're going to swap 12 with 0. And then at the end, all our zeros will move to the end, and our sliding window will have done that for us. So to visualize this a little better, what we're going to do is we're going to create window start equals 0. Window start is going to be this first square bracket here. Window start end. Oops, my bad. Window end is going to be this end bracket here. And so we want to iterate while window end is less than the length of nums, because you want to do this in linear time. And the cool thing about the sliding window pattern is that we want to operate only on start and end here, just to keep this in linear time. But you can use this for other things like running sum and stuff like that. So, as we saw before, when the number is 0, the next number in the list that we're looking for is 0. Let's say we have 0, and we'll delete this and we'll start all the way back here. When the number is 0, we don't have to do anything. We just have to go to the next iteration, because window end is going to increment. It's going to move our window up. This is what we want. So we're going to do that here. Window end equals window end plus 1. The caveat here is that the real action happens when the next number, window end, in this increment here, is not 0. So what we're going to do there is that little switcheroo that we talked about earlier. So we're going to do if nums sub window end does not equal 0. So we can see here we started at 0. The next number after we incremented window end equals window end plus 1 is no longer 0. So what we said we were going to do when that happened is we were going to swap the numbers. So temp, oops, I'm just going to do a standard swap. I know you can do this in like one line in Python, but I don't use this language. Nums sub window end, and we're going to do nums sub window end we're going to save that. Num sub window end is going to be equal to nums sub window start, and then nums sub window. I think I did this wrong. Num sub window, and we save it, and then num sub window start equals 10. So the reason we can swap this so easily is because window start, we always have a reference to the start of the window. So window start here is going to be here, and it's going to be this index right here. So we can just swap these two numbers, window end and window start. Now the important thing here is that after we swap these numbers, if we just do this, then our window is not abiding to the rules anymore. So what we have to do to make sure that this window is always following our continuing array of zeros, let me just add some more numbers here. What we have to do is we have to slide the start of the window up once we swap a number. So to do that, we're just going to do window start equals window start plus 1. And once we do that, we can see how this kind of gets us to the end. Well, these two numbers aren't the same, so we're going to do the swap again. Move our window up. These numbers are the same, we just increment normally. These numbers aren't the same, we swap them. We swap 9 and 0. And so on and so forth until we get to the end. So I think this should be good. I feel like it's missing something, but I don't remember. Let's see. And then at the end, we'll just return num, since we were supposed to do this in place. Yeah, so this is good. We passed that test. And we passed it in 90% of the solution. So it's pretty good. Sliding window pattern is super useful, so you just want to make sure that you can apply this. There's a bunch of solutions you can do here that don't really apply to other problems, so it's always better to use some kind of pattern that you can use to different problems.